Good morning, all. It's my pleasure to introduce Dr. Professor Rahul De, former Hewlett-Packard Chair Professor in ICT for Sustainable Economic Development at the prestigious Indian Institute of Management, Bangalore. A distinguished academic, Professor De is a leading voice in the domain of information systems and artificial intelligence. His academic journey is marked by excellence, having earned his BTech from Indian Institute of Technology, Delhi, his MBA from Faculty of Management Studies, Delhi University, and his PhD from University of Pittsburgh. Professor Day's research is both extensive and impactful, focusing on critical contemporary issues such as AI ethics, e-government systems, open source software, digital payments, telemedicine, and broader field of information and communication technologies for development. His scholarly contributions include several books and over 50 articles in esteemed international journals and conference proceedings. A testament to his significant contributions to academia, Professor Day has been honored with numerous international awards for his research and teaching. He is a highly sought-after speaker and has shared his expertise at various national and international forums. At IIM Bangalore, he has held several key administrative positions, including Dean of Programs and a member of Board of Governors, shaping the institution's academic and strategic direction. His dedication to fostering the next generation of leaders and his profound insights into the evolving technological landscape make him a truly invaluable asset to the academic community. And herewith, I welcome you, sir, for today's talk. And before that, I request our director, Sir Dr. Gopal Patra, to hand over a memento to him.
Oh, so nice. Thank you. Thank you so much. Thank you.
This is just wood color. This is color painted.
Ah, oh, lovely.
Color of the wood.
Wow, beautiful. Thank you so much.
Sir, as data scientists belonging to various domains, all of us are eagerly waiting to hear you.
Okay.
So, floor is all yours.
Okay. Thank you so much. I guess I can stand here and speak.
Yeah.
Or okay. So, mic is okay.
Yeah.
I'm audible. So first, let me thank Dr. Ernest, who's been interacting with me, and Dr. Patra for inviting me over. This is a beautiful campus. I'm so happy to be here. I'm seeing this for the first time. I was just talking to Dr. Patra, and he mentioned Professor Yagnik, whom I used to know many years ago. I interacted with him. So there is a small connection I have. Otherwise, it's my first at this institute. And today I have a lot of slides for you. I will talk about AI and different kinds of AI and data. Maybe I'll stand here. It may be a little easier. Some applications of AI, what is happening in the world. Then I will move on to data, because the topic that Dr. Ernest suggested was look at data. I think all of you work a lot with data. Data is a huge issue now, and I will go over a lot of those things with you. There are some responsible AI concerns, and towards the end I will close with this whole concept of data stewardship. So let me jump right in. I'll go through a whole bunch of slides, so we will have some time for a discussion later on. So if you're finding some of these things a little strange, I can address these. So I'll begin with my, at least beginning from first principles. What is AI? I want to establish that, because a lot of things are being said about AI, which I would like to clarify from my perspective. So the term is about 70 years old. It was coined at this institute. This is the Dartmouth College in the USA in 1956. A bunch of researchers, about 10 of them, gave a proposal to the National Science Foundation, in which they used this phrase. What they wanted to do was making a machine behave in ways that would be called intelligent if a human were so behaving. Please note that the reference point is human intelligence. And that has always been the hallmark of AI, that they want to replicate human intelligence, and that's why the phrase artificial was used. They were very clear, they didn't want to create another form of human intelligence. They wanted it to be artificial, to be implemented in silicon or computers in those terms. What is AI today? What is being called AI is basically take a lot of data, lots of it, and find patterns in it. Again, these are mathematical patterns, and build something called a model. And that model, whether you call it ChatGPT or something else, is then used for what is called inferencing. The first part is learning or training, the second part is inferencing. When you give it some new data, it will give you three things, three kinds of outputs, as we can see amongst all the things. One is predictions. It can give you predictions about the market, about the weather, about whether a person will buy something or not. It can give you classifications. Is this tissue cancerous or not cancerous? A classification. And third, it will give you generative output, which is it will make a picture for you. It will generate code for you. So those are essentially three things AI is doing nowadays as we understand it. I've given some examples here of the inferencing part. If you give an image of objects, it will give you the labels. If you show somebody playing football, it will tell you young people playing football. If you give it images again, it will give a caption for that picture. If you give voice recordings, it will give you a transcription of that voice recording. Or it will translate it for you. If you give loan application data, which is happening a lot with banks, it will tell you whether to approve or deny the loan. If you give credit card data, it will tell you if this was a fraudulent purchase. And maybe some of you have credit cards where you get that thing, that clarification. If you give sensor data from engines, it will tell you, is this engine going to fail? And this is happening a lot with aircraft engines, for instance. If you give chemical properties of drugs, it will predict the efficacy of drugs. If you give, the last one, if you give language instructions, and this is happening with generative AI, it will give you the blueprint for a building. So this is where it's at, the AI is at today. How good is it? This is a classic example from a Kaggle database. Maybe some of you are familiar with Kaggle. It's the competition site. These are muffins and dogs. If you look at the diagonal from top left to bottom right, that is the top left one actually is the most confusing. It always looks like a dog to me. It's not, it's actually not. It's a muffin. And this is a classic classification problem. It's been there on Kaggle for a long time. By 2017, the accuracy was already better than humans. It was at around 3 to 4%. Today, it's much better. Human accuracy for these kind of images, and I use this in classes many times. There are 16 images in here. People stumble on 3. Sometimes they get that top one off. They sometimes get this one off also. And this last one here also is a slightly tricky one. They get it off. So for certain kinds of tasks, certain kinds, not all, the accuracy levels are very high. For instance, there is a hospital in Bangalore which relies very heavily on this classification task for predicting certain kinds of stroke repercussions. Now, what kinds of AI are there? I would like to separate things out for you a little bit. Artificial intelligence is a big field by itself, and it emerged in the 1950s. I joined an AI program for PhD in 1987, and at that time, I recall we had a textbook. I still have it with me. The textbook had 15 chapters. The first 14 chapters had nothing to do with machine learning. The last chapter was machine learning, and the professor skipped it. So we said, why did you drop that? He said, it doesn't matter, it's not important. Today, machine learning dominates the field completely. But again, many people don't know this. There's a lot to AI which is not machine learning. There's logic, there's reasoning, there is a lot of the language processing things which are not strictly machine learning. Within machine learning, what dominates the field is this thing called neural networks. See, the simple mathematical calculations that you do with neural networks. This begins with a simple neuron, and those neurons are put into a whole collection. So you have now billions of neurons going into a network. Then those form deep learners, which are doing a lot of these very difficult problems of classification and pattern matching. And within deep learners, there are these large language models. So all this discussion on ChatGPT and so on is basically they're building more and more sophisticated neural networks. That's basically it. So if you understand the core concept of a neuron, you will understand the other parts. The mathematics actually is not very hard, not very hard. Now, within machine learning, there are three kinds of fields. Now, notice this, this part here, the first part, what is called supervised learning, needs labels. Labels are basically categories to data. The dogs and muffins, you have to say, this is a dog and this is a muffin. And then it will figure out how to classify. Unsupervised is an approach in which you don't need to label. The algorithms look for patterns in the data, and they find some patterns which are useful. So in some ways, unsupervised is very powerful, but it's still underutilized. Most of the world is working with supervised learning. There's a third one type of learning called reinforcement learning, where you don't work with data, you work with actions. It's learning to do things. So a lot of robot design goes into this. Of course, it's now coming into other kinds of activities like stock trading. Stock trading is a patterned activity which you can figure out what to do. Now, these are the three kinds, broad kinds of machine learning. Let me put at least my view on this. If you guys disagree, I'm happy with that. But I think AI and data science are two very separate fields. They grew separately. Data science is what we used to call statistics, operations research. A lot of that goes into data science. AI grew as a field more out of computing. But today, there are huge overlaps, huge overlaps. So at one point, one begins to confuse the two issues. I have written a textbook on AI in which I'm saying the same things. I have focused on the AI part of it, not on the data science part of it. My textbook is called AI for Managers. My colleague, Professor Dinesh Kumar, has also written a book called AI for Managers in which he focuses on the data science part of it. So both of us are addressing the same community, but we are saying different things. And that is fine, that is fine. That's the way fields emerge and grow. Now, what is it that made AI come up so heavily? I said I joined a PhD program in 1987. I finished in 1993. I could not get a job. In a business school, nobody knew what AI was. I had to reinvent myself as an information systems professor. That was a recognized field. So I could get a job. I came to IIM Bangalore in 2002. I offered a course in AI. Very few students took it. And at the end of it, they said, why are you teaching us all this stuff? It looks pretty good, but what's the point? Okay, no value. Now, today, before I retired, even just now, just last month, I finished teaching a course. I can't keep students out. They're all flooding my classes. Even though I've retired, all classes are filled up. Why? The progress is because of these three things. In 1989, when I started my thesis, I had to spend 2 years collecting data. Today, we have data in huge quantities. Sensors everywhere, there's social media, and I'm going to go into details on that a little later. There's massive data. There's cloud infrastructure. I think you guys also have access to a huge cloud. Cloud computing has gone ballistic. I wrote my thesis on a desktop computer with 640K of RAM. Please note, K, 640K, 20 meg of the hard disk. Today, you can't even think of such things. Even your phone has more capability. That's cloud computing. And third, open source software. I wrote my software. It took me 6 months to write all the code in an arcane language called Lisp. Today, you have all these languages like Python, R, Julia, and so on, which are hugely popular, very well very well, easily available and open source. So I think these three, data, hardware, software, is what drove this revolution today. All of us can get access to this very easily and start experimenting. Now, what's happening with AI? I used to call this a speculative slide. Today I will say I'm not speculating anymore. AI today is basically at this point here. This is where we are. Artificial narrow intelligence. AI can do small things like Google Maps. It's AI. It can tell you maps. It can't do cancer diagnosis. You have a chess playing program. It can play brilliant chess, better than any human now. The alpha chess and all that, but it can't play Go. You have a Go playing program. It can't play chess. Narrow intelligence, very, very deep capabilities. Now, the original goal of AI was artificial general intelligence. What you wanted was human-like intelligence. I am not a great chess player, but I can play chess. I'm not a great Go player, but I can play it. All of us can figure it out. We have general capabilities. I'm not a doctor, but I can do some diagnosis. That capability was the goal of OpenAI, the people behind ChatGPT. They explicitly stated this in a book I'm reading right now by Karen Howe called Empire of AI. They wanted to build AGI. And they're claiming ChatGPT is AGI. It can play chess, it can do programming, it can do maths. There are other skeptics who don't accept that. They're saying we don't know if that is true. Then there is this goal, which even last year I would have called it speculative. I've stopped saying that. Why? Because Mark Zuckerberg is pouring in billions of dollars in this one, super intelligence, where the AI capabilities far exceed human capabilities. If you want to prove a theorem, don't bother, ask ChatGPT to prove it for you. That's what they want to go into. If Zuckerberg has his way, he will build this. You know that he paid, whatever, hundreds of crores to hire all these people. He is after this goal. This is pretty much Hollywood stuff, I used to think, but people are serious. They're putting in big money into this because that's where they want to go. So these are the broad goals of AI. Now, let me just run through a few applications just to give you a high-level view of what's happening in the field, which are actually working AI tools. Take a look at this one. This is brain X-rays. This is being used by a hospital in Bangalore. When a stroke patient comes in, they take X-rays of the patient. Stroke as a disease has a small window in which you have to do the treatment. Otherwise, it can become fatal, or it can have very severe consequences within 4 to 6 hours. So doctors have to move fast. And what they did was they started relying on AI. It looks at a picture like that. Those are various views of the brain. And the AI basically answers this question. Do you need surgical intervention? If you need it, you have to move now. Instantly, you wheel them into the operation theater and you get going on it. AI will give you a high probability figure. AI will give you a probability figure whether you need surgical intervention or not. Now, take a look at this one. This is chest X-rays. This is a very successful company based out of Mumbai, which has now got clearances from countries around the world. They will look at chest X-rays and try to predict for a patient maybe who has some symptoms, what exactly they have. Is it pneumonia, cancer, tuberculosis, healthy? They can even predict COVID. This is a company called Cure.ai. Okay, they're very successful, doing this very well. Take a look at this one. This is a company, actually there are several now in Bangalore, who will look at resumes of candidates who are applying. They look at resumes and social media data, and they are able to predict whether this candidate is suitable for your company or not. They do the shortlisting. Typically in India, you apply, you put up a post, you will get 50,000 applications, and screening is a very difficult thing. They do the screening for you. They might give you a list of 25, you interview those 25. Again, very accurate as they claim. take a look at the next one. This is a company again based out of Bangalore which looks at satellite images. And it has done this categorization where it will take this picture, maybe that picture is from Mandya district, and they will tell you how much sugarcane, ragi, rice, wheat, or whatever is the season will be the yield from that plot of land. They've taken a lot of pains to curate this data accurately, and they are so successful. They've been, they've got clients all over the world who are asking for this. What is the prediction of the yield from this satellite image? This is very useful for agricultural marketing, for instance. This is something you must all be familiar with. There are programs like Replit and Cursor and Lovable which will take a prompt for code from you. Even Grok or Claude will do that for you and produce perfectly functioning code. Python code will do it, any other code, I guess you must have tried, I've also tried. They will produce perfectly functioning websites for you, e-commerce sites for you. They'll just do the whole code. These are successful applications. This is taking over the world in a lot of industries. Just yesterday I was with basically a multinational bank. Everybody is using this application, very widely used. So there's just a sampling of what is happening in the world. This is called vibe coding. Now let me focus on that part about data, and that's the focus of this talk. I said all this just now to set the ground for it. What is happening with AI and data? First, I will call this the yin-yang of data. You must have seen the yin-yang symbol, the white and black. So in Chinese culture, the yin and yang are basically opposites, but are complements. They're not only opposites, they're complements. You need both of them, but you can't have them together. They'll be separate but together all the time. So male, female, day and night, etc. are the yin-yang. So I'll give you the yin-yang of data. Take the first one, cognitive processing. This is more to do with types of data. This is one type of data you and I use on an everyday basis, which is either text or numbers. This is symbolic data. Typically, this symbolic data, this is the data that we have learned to process. We were not born with it. We were not born with language or mathematics. We learned it over a period of time. If you look at the next one, subsymbolic, images, senses, touch, this data is what we were born with. Our DNA tells us how to process certain kinds of images or touch, whether it's hot or not. Our DNA tells us. So that's subsymbolic data. This is the yin-yang of this cognitive processes that we go through. Take a look at the next one, domain of data. One domain is human activity. So what we do, whether you buy something in the market or whether you log in and read some newspaper reports or you create some reports, this is human activity data. This is related to your society, economy, your activities, the work you do. Then there is the environment, something many of you are interested in. The environment data is not connected to humans. It's related to weather. It's related to clouds or to stars or to the earth and so on. Satellite images, geosensors, weather data. Again, yin and yang. These are related, but they're not the same. Third one, property rights. There is data that is freely available. Government creates free data. We put them on our website. There's something, I can point a camera outside and take a picture. That's free, supposedly, although there was a sign outside your gate saying you can't take pictures inside. That is the second part of it, protected, copyrighted data or protected data. You can't take a picture. Yin and yang of this. There is a huge controversy now erupting on this, and I'm going to go into that, the whole concept of sovereign data that is coming up. So property rights, take a look at sources. There are some sources which are analog. Look at old records, land records, newspapers, birth certificates. These are analog, they were written on paper. Today the whole thing is getting digitized. A lot of this data is digitized. Again, yin and yang, they go together, but they are not the same. Third one, authentic versus synthetic. Authentic data is I took a picture of the flower outside. Synthetic is I made a picture of the flower outside. They may be similar, but they're not the same thing. The source is where we have the contention. And there is now, as you know, there is a whole industry which is saying this is authentic, this is not. And we have this whole idea of fake data, of fake news, fake images that are coming up. And we have to identify what is fake and what is not fake. So these are the yin-yangs, the kind of the flip-flops, the binaries of data that trouble us. Now, AI and data. The big move of AI and data happened around 2012 when the deep learning explosion happened. That's when, in that year, the ImageNet challenge was won by this program called AlexNet, which improved the accuracy levels of that dog and muffin kind of problem by orders of magnitude. Like it went up like 15% or so. It was at 70%, they went up to 85%, and later on they went up to 90%. And that's when they realized if you throw more data at AI, it works better. That was the broad insight people got. And then the whole world started jumping up and down on data, and data, that cliche showed up. Data is the new oil. It is a resource that you have to protect and use. The second one came with ChatGPT, 2022, hardly 2-3 years ago. ChatGPT, they were working with language models before that. I had tried GPT-2 and GPT-1 and so on. I tried them. They were okay. They were not so great. But suddenly ChatGPT said, okay, I'll push massive data through this. This is 300 billion words was used to change GPT-3. The next one is even GPT-5. Actually, people don't know how much data was used. It was massive. Day before yesterday, Government of India announced that they're going to build a huge model, 1 trillion parameter model, which are going to put massive amounts of data in it. So data has, this is the push behind AI and data. The more you put in, the better it is. That is a belief. Now, human domain data comes from, I'm going to say 3 kind of sources. One is the societal, the social media, society. A lot of things that you guys are putting up on your Facebook, Insta pages is data for these engines in massive quantities. Even cultural production, the movies we make, the books we write, the poetry you put out, the email you sent out, all of that is becoming data. There are issues with that, but that's the societal source of data. Economy, when you do a UPI transaction or you go to the airport and use DigiYatra, you are creating data. If you're doing commercial transactions, you're buying things, you're doing banking, etc. That's the economy data. And the third one is industry. Anybody who's mining, making things, even doing services is generating data which is in the human domain, which is connected to us in some manner. This is going into the whole AI engine. Now look at the ownership challenge. This is where things get a little sticky. I'll begin with this side here, sovereign data. Because of DeepSeek, which came out earlier this year around January, and Trump tariffs, all governments are now worried that, okay, we cannot rely on ChatGPT and others to give us AI, we will build our own. So because of these tariffs and this whole regime where things might get restricted, so as you know, BharatGen is supposed to build this model. Then this is sovereign technology, sovereign AI, which is related to a nation. Then comes the whole concept of sovereign data. Now, the challenge here is if I have records of X-rays in a hospital in Bangalore, those X-rays are used for AI. I just showed you examples. Are those X-rays ours? Are they India's X-rays? They belong to patients who live here. Maybe some people come from other countries, but mainly they have been collected here. There are millions of images. They can be very usefully deployed. The question is, are they owned by the nation? And are there going to be laws which will say, sorry, I'm not going to give this to you? Is ISRO data collected by ISRO satellites sovereign data? Okay, those are the challenges. Now, one theory of data, and I'm quoting again a Bangalore-based researcher called Janki Srinivasan. She's just moved out actually. She was in IIIT Bangalore. She says that data is rooted to a context. when you detach data from its context, it loses meaning. So according to Srinivasan, if you detach data, meaning you take the data, those X-rays out of the hospital in Bangalore, and you take them to California and you build models with it, you have lost a part of their meaning. Now this makes sense. This makes sense. Okay, we talk about this in a big way. She has theorized this. It's an excellent book. You might take a look at it. It's called The Political Lives of Information. So this is the ownership issue. Now take a look at what are we talking about when we get to talk about responsible AI and ethics. Here a bunch of things come up. Why is this important? It's important because AI is making a lot of decisions for us, huge numbers of them, including telling us where to turn. It took me 1 hour, 10 minutes to come 11 kilometers today. I think there were mistakes. I would have taken a different route. But it's a critical decision. I would have been grossly late for this talk if we had relied on it completely. The driver was using something else. There are huge issues of fairness, reliability, ethical violations, regulatory compliance, and so on. So it is very important that AI is used, data is used responsibly, AI is also deployed responsibly. So along with all this data and compute and cloud is the responsible AI thrust that is coming. And I'll take you over some of those issues that are creeping in here, particularly related to data. So some recent incidents. This you may be knowing about this. This was a few years ago. Amazon was rejecting female candidates. So Amazon is a famous company. They get a lot of applications, and basically girls were being rejected. Girls protested, then said, "Go check this. What's wrong? I'm as qualified as the guy you recruited." And then Amazon checked their records and said, "Yes, you're right. We are rejecting girls." Why? Because the training data was based on their current employees who were mainly boys or men. So you reject all the girls. So they actually agreed to this. There was a court case, and they had to back off. Clearview is a company based out of Britain, which basically, this was again in the mid 2016, 17. They scraped data from Facebook basically, and illegally started identifying people. So they literally gave this software to people. You go into a party, somebody standing there, you point your camera, and so, "Oh, hi, Mr. Ashok." You say, "Oh, how do you know I'm Ashok?" "Oh, well, I know because I have a software which is telling me you are Ashok." They got sued and they had to back off. They just took data. From then on, these issues came. These two ladies, Bulamvimi and Timnit Gebru, MIT scientists, who were black ladies, who went and showed that facial recognition systems will not even recognize them as people. So they stand in front of the camera, it gives a blank, doesn't say anything. Then Bulamvimi took a white mask, she cut out the eyes and nose and stuck it on her face, and then stood in front of the camera, it says, "Yes, female." So they show that there's huge bias built into facial recognition. Social media, you guys must be knowing about the Cambridge Analytica story, where they basically influenced two elections, two voting. One was in the US, one was in the UK, by manipulating news based on data they had scraped again from social media. Now, two recent incidents. These happened basically last week. This is the Anthropic company was asked to pay $1.5 billion. Now that's a lot of money for Anthropic, but they were asked to compensate authors whose books they had illegally whacked from LibGen. Are you guys familiar with LibGen? The younger people would be familiar, right? So they had gone and cleaned out LibGen. It's a huge repository of pirated books. They cleaned it out and they used it for their training. Judges said, wrong, you will pay the authors. Those authors were given like $100 each, but it cost them $1.5 billion. So this is an interesting case because it is now saying that, look, you can't do this. You can't just take somebody's book. Will somebody take my book and just clean it up and use it? I may not complain, but my publisher will. As an interesting aside, just 2 days ago, I was looking for images on Copilot. I said, give me an image for this. And Copilot started telling me the source. This had never happened before. It would just generate an image. Now it says, oh, this is the source for where I got this from. This is the impact of this ruling. Data theft, this company, well, Salesforce is a major e-commerce company. They are in the background of a lot of other companies who use Salesforce. They lost 1.5 billion records. And this affects 700 companies around the world. Basically, think of it this way, yours and my data is now with some hackers somewhere. If we have used anything that Salesforce does, which may be something we may not know, any site could have this. And this was because of an AI agent called SalesLoft Drift. It was compromised, and some hackers figured it out, and they stole this data. Salesforce is still trying to figure out what to do about this. It's still too early. They admitted in August that this had happened. So these are incidents about the ethics of data. I'm going to give you 5 of the kind of the high-level issues that come up. These are very well talked about, so I won't go into them in much detail. Bias I've already mentioned. Output should conform to known metrics of justice and balance. Some sense we have that it is just that if you're rejecting women candidates, it is not fair. There's something wrong with that, even though you may mainly have men in your company. It is not fair to reject. That's bias. Then you have transparency. How are you using, where did you get this data? If you're using X-rays to tell me about my health condition, where did you train your AI on? Can you please tell me if it was Italian data or it was Indian data? Fairness. This is related to bias. Am I being treated equally across groups? If I ask for a loan application, will you reject me because I am retired, or will you accept me? If I change the retirement to not retired and you accept me, there is something wrong with that picture. Fairness is not involved there. Accountability. Who is responsible? If the Google Maps is giving wrong directions and it messes up your interview, you're going for an important interview, who is responsible? Google Maps will say, forget it, I am not responsible. You figure it out. So these are challenges. Privacy, this is Indian government has implemented the DPDP Act. As you know, we have a certain right to privacy. And this has to do with basically the right of individuals to have autonomy and control over their matters. So data is very directly affected by this because AI is eating up a lot of personal data that's coming into this. Now, the labeling. Now, I'll go through some of these aspects of data ethics which are important. Data labeling is a massive industry. What is data labeling? I showed you an example. Show you a picture, you say this is a dog. Show you a picture, this is a muffin. Now, is this hard? Yes, it is. When data goes into billions of images, it is very, very hard. And that is why in 2012, when the ImageNet challenge was going on, this lady called Fei Li, she's a professor in Stanford now, she was earlier in Princeton, she had these basically 5 million images, which seems small by our standards now. 5 million is what, like 50 lakhs images. So she was getting students, interns to classify them. This has a boat, this has a dog, this has a... She says, look, if I go like this, I'll spend another 30 years doing this, I'll still not be done. So she started using this Mechanical Turks. This is an online site, it's a crowdsourcing site, where you pay people one cent per image, and they'll say, oh, this picture has a dog, and this picture has a flower, and this has a cup, and so on. It'll identify. And then they realize it won't do, if this is the picture, one person says it has a water bottle, the other says it has a glass, now you're stuck. Which one is it, water bottle or glass? Actually, it is both. So what you do is you get 9 people to label this. and then you take the modal value. Because if you take a picture of, outside on the street, you don't know what is the picture. Is it a tree or a scooter or a shop? So 9 people, if they say it's basically a shop, okay, you put it there. So that labeling is so hard. Another example, all of you would have some Alexa at home, or you're familiar with Alexa. Alexa is collecting all those sounds. Okay, you in your house, opening door, opening fridge, sitting on sofa, dog walking around. Who is labeling that data? Alexa is labeling it. They're collecting it and labeling it because they want to make more products on it. Labeling is being done by people who are sitting and listening to all this. Oh, that looks like a dog. Because you can't productize any of this unless it's labeled. It's a huge industry. Recently, a company called Scale.ai was purchased by Meta at massive multi-billion valuation. What do they do? Labeling. Now, there are labeling biases. Lot of this labeling is done by marginal labor, people who are living in slums in developing countries. Kenya is one place where one guy was labeling these, these pornographic images. He had severe mental health problems because they were horrible images, and he had to watch them and label them. So he gave up. He sued that company that was making him do it. Many of them are migrants who have moved to other countries. They are educated, but they don't have any rights to work, so they do this work stuff at piecemeal rates. 1 rupee, 2 rupees per label. There are labeling biases involved. There are biases involved with people. Somebody in Africa won't know what is going on in India's situation. They're just not familiar. So there are annotator biases, there are contextual biases, there's different standards, interpretation of what it means to label something. In India, things are very different from what would happen in Europe. So this is a challenge. Labeling is a challenge. Now, look at the whole issue of synthetic data. Synthetic data is data which is basically simulated, and it is based on the same statistical patterns. So how do you create a synthetic image? You take a bunch of pictures of the flower outside and you approximate its distribution, the distribution of the pixels in it, and from that distribution you take a sample out which also looks like that flower. It is not the same flower, but it has the same properties as the flower. So you say this is synthetic data. And this is being used very, very widely now in all domains. In medicine, in science, in research, hugely synthetic data is being used. Why? Because you don't have a privacy problem. If you don't have enough lung images, and lung images are protected under privacy laws in India, you use synthesis. You take some legal lung images and X-rays of lungs and you generate. So privacy is not an issue. You have regulatory compliance, again same as privacy and other laws. You essentially need lots of data to train models. If you don't have enough, generate it. You have basically control over the generation, what data is coming. But there are huge ethical challenges. If the data has biases built in, that bias will show up in synthetic data also, because the distribution will be reflected there in the synthetic data. And there are these whole issues of quality. The provenance is where the data originates from. I have a slide on that. And of course, whether it represents the real world or not. Now, provenance is where the data came from. What we are saying is you need a historical record of the data set, how it was obtained and where it was created. This is basically a version history, an audit trail of the data. If you say I collected the data from a hospital in Bangalore, we should be able to verify that hospital gave you the data. And you didn't just make it up. And this is becoming a huge, huge problem. And people are asking for provenance. One of the challenges with establishing provenance is when you go and grab data from all over the place, which companies have been doing, you cannot establish provenance. In fact, you will not do it because that will put you in trouble. Just like Anthropic got into trouble. They had a very hard time admitting that they were going to a private pirate site and stealing books. Actually, there is no stealing on pirate sites. They were downloading books. So they had to be red-faced while admitting, yeah, we were doing this. There is a huge problem of this provenance, but this will happen. There will be issues of compliance, there will be issues of audits and transparency, and there will be documentation challenges that will come up. Companies are facing this. I can take a simple example. It's happening in my institute. When I was dean, we were asked for certain data by a regulatory authority. We provided the data. Then they said, this doesn't seem right. And we were red-faced saying, no, it's right. Then we went and checked. It was wrong. So we had to say, sorry, this is wrong. Let me correct it for you. It's very, very troublesome. And we can get into trouble. Of course, we try to take care of it, but we have to be careful about it. Then open data. Governments around the world since the 1950s have been saying we should make data open, data public. For instance, ISRO is a public institution. If they take satellite images, it should be available to us to do research with, to work with. Open data. Now, if we can do it, well, so can other countries. Now is are we going to make it open? This is becoming a challenge now. So Americans have been putting out a lot on open data. Actually, many countries. In fact, I've put a number there. 197 countries. There are, assuming there are 205 countries in the world. That's more or less all of them are putting out open data. They're putting their data on their population, on their economy, etc., out in the open. It ensures transparency, provenance is known, etc. But there are challenges. There's lack of standardization. There's fragmentation, and it defies sovereignty, the issue I'd raised before. If it's national data and you make it open, well, it's not national anymore. China will take it, and you may not like it. China took our data and worked with it, and we can do the same. So there are problems with open data, but that seems to be the way out. So let me come to this last part here. What is the notion of data stewardship? The data stewardship is, because this is a huge issue, there's so many things about provenance, about synthetic data, about quality, etc., that we have to actively manage data now. As an organization, as a country, we have to actively manage data, be very conscious of it, so that all these issues, quality, compliance, ownership, provenance, authenticity, access, usefulness, are in a way in our conscious minds when we are working with data. So as data stewards, we have to recognize the ethical foundations of AI. We must address the entire data life cycle, how data comes from where, the provenance, and how it is used and stored and for how long it is maintained. We have to look at labeling practices which are very exploitative, and we cannot let that go off, casually ignore it. We have to balance openness and sovereignty. Once you open data, it cannot be sovereign. If you keep it sovereign, it's not open. We have to sustain proactive measures and continuous monitoring of how and where data is maintained over a period of time. That is the stewardship issue. I will close here and take questions. How am I doing on time? I think I was okay on time? Okay, thank you. So this is it. Yeah, sure.
You told that this annotation work, it is taking so much of expense. Why can't we automate the process of this annotation work?
This is the horse and cart issue. To annotate something, you need to have labeled data to train the AI which will annotate. Now to get labeled data, you have to annotate it. It is a circular problem. I'll tell you, see, you're asking a good question. I've often asked the same thing. This, there is stuff on the internet. Pornography is one of them. There's other stuff, all this they're butchering people, killing people, this, that. Some people take pictures of it, images of real images, and put it up. Now, can we have a way of synthesizing all that bad stuff, labeling that synthesized data, using that to train AI and say, okay, this looks like pornography, this looks like violence, which we can flag. People are doing that. People are trying that, but it's still very difficult.
But can we use some already pre-trained model and use it as to annotate our data?
Yes and no. The old stuff, yes. See, if you take pornographic images, you can train a model to recognize pornographic images. But it will still remain in that domain of what it knows as pornographic images. If there is something outside the domain, it will be lost. It won't be able to classify. And you are looking at millions of images here. Huge, huge numbers. So you are stuck with that chicken and egg problem constantly. But that, in a way, is where people are headed. That's the only way you can solve it in a clean manner. Take cancer versus non-cancer images. You can take any. I'm just using cancer as an example. Anywhere where a doctor can visibly recognize a disease pattern. It could be something on the skin. It could be something in a tissue. Now, how do you classify those without the doctor? It's the same problem. The doctor knows something about that image, so you have to train an AI at least once with the doctor's help, and then go ahead and train classify the rest of the images. Maybe that will work. People have been trying it. It does not. Accuracy levels don't remain the same. They begin to fall. But yes, you're pointing to the toughest problem in there. Very hard. Yes.
Many quality contents are copyrighted today.
Mm-hmm.
So for these large language models sort of stuff, would they face a larger challenge in terms of using this data? Because eventually they may not be allowed to use a copyrighted data, right?
Yes. So far they've been skirting that issue.
Yeah, so far it was sort of okay. So
Yeah.
But the coming days is not going to be like that.
It's not going to be. See, part of the thing is it's already out. So
it's sort of a stealing, right?
yeah, I stole it. Now with digital data, once it's stolen, it's gone. So it has gone into the models. Take an example, all those few thousand books that they stole, it's already ingested into Claude. Now what you can do is say, okay, I won't touch all that books before, but you've taken everything anyway. Now what they will do is, what he's saying in a way, is you will use Claude to distill. So you will write queries and Claude will spit out the answers. No, those answers are coming from books that they have hacked. For instance, that like you can say this, write a memo to my friend to invite her for tea this evening, write in the style of Shakespeare. Now, how did you get the style of Shakespeare? You hacked Shakespeare. Shakespeare is out of copyright, no problems. Now, if you do that, write that in the style of, today, any author from the Indian subcontinent, it is a copyrighted work, you can't do that. Take Chetan Bhagat, write in style of Chetan Bhagat. Chetan Bhagat's books are still in copyright. If you do that, that means you hacked his books illegally. Now, you can say, okay, sorry, I took it illegally. Chetan Bhagat, here's $150, sorry. But I have ingested all of your books and I am going to write that email in the style of Chetan Bhagat. I will get away with it. And there is another issue I didn't raise, it's the autophagy issue. If you see, Chetan Bhagat did not write, let's say, a book on cricket, let's say. Now you write a book on cricket using Claude. Say, write a book on cricket in the style of Chetan Bhagat. It should have this character who's a bowler, this, that. You can put all those things and it writes a book. Now you take that book and put it as input. First, we have this synthetic data. We have a problem. Now, first Chetan Bhagat might say, you cannot steal my style, which people have done. Anil Kapoor, he went and he won that case about his that famous line of his chakas. Any of you guys know that movie? I haven't seen it. Some movie in which he says chakas in some style. Now they had copied it, so he objected. He won the lawsuit. So High Court said no. But that is gone in. Now you can make some other character say chakas in a slightly different style. And now you are stuck. Anil Kapoor can't keep coming back every day and say, that is my style. Anybody can say chakas. The origin. So it will be a complicated mess that will show up somewhere. But yes, I see it headed that way.
The future LLMs might find that as the biggest challenge, right?
Probably,
Yeah.
yes.
To some extent, the learning algorithm is known and can be handled, but then this availability of this huge data and
Take a look at what's happening with coding. A lot of code is being generated through LLM. GitHub originally was full of code written by people.
now it is full.
Now, give it another year, it will be flooded with code written by. Now what do you do? So, does the copyright issue vanish? Probably.
Like a new face altogether.
Yeah. we have a problem that is going to be hugely challenging. There's so many of these. They've taken all the prominent political figures, their speeches, like Narendra Modi's speeches, his style of speaking, etc. Is that copyrighted? Can you take that? People are already generating videos on his style. He has a particular style, and so does Trump. So you endless videos on Trump.
They fight each other. So
Why? His style of speaking, you can go on and on. Then you can use that as a feed to do that. So whether this we don't know these answers. These are very tricky issues. Yeah.
How will be the future of AI if it keeps getting trained by the data generated by itself? Because over the period, because it's a feedback loop, isn't it?
It's a feedback. They call it autophagy. There's a name for it. There is a paper on Archive which says that autophagy leads to. They actually gave it a word, the phrase, acronym MAD, mutually something destructive. It goes haywire. What they did was they took images generated by AI and fed it to AI to it goes bizarre. You get really fragmented, strange images coming out. So that human domain versus the authentic versus synthetic, we may actually pass laws in our country. We are headed towards that, saying, look, if you build a system which will affect us, say either in medicine or in education or in say banking, finance, etc., which affects us, it has to be based on authentic data whose provenance we know. We may pass laws to that effect. That's the only one that will solve it. Otherwise, we are going to be in. It's a substantive challenge, this whole synthetic and provenance issue. The sovereign one is the other challenge, which I don't know how to solve that. I'm just going off the topic, just taking. I think right now about 7 Indian companies have been identified to build the Indian AI through the Bharat AI mission, something like that. Sarvam is one of them. Sarvam, day before they had Bharat Gen, and then Gyanan and some Gyani, the other 2-3 other companies that they have listed. Many of them are actually they are building on top of Chinese models. They took Quen and they took additional data and they are training Quen on top of it. Now, that's fine. Why will you reinvent the wheel? You know, you have a wheel in there, it's running fine, you go and build on top of it. To me it makes sense, common sense. But people may object, saying this is violating sovereign conditions. China may step in and say, hey, what's up? It's like the whole Trump issue, you can't use this. So again, we'll have to work this out. This is very vague right now, unclear. Bharatjan is saying we'll take only Indian data. We don't have enough data.
But one thing, like what you said, Trojan models, what people are talking about, I mean, will it sustain? Because I don't think any data which is Indian data is really Indian data. It is already taken by
By a huge number.
I mean, for example, DeepSeek, you see, I mean, if you use it, it gives as accurate as information which is related to India, Indian culture, Indian cinema, everything. So there is our Indian data.
Large portion is already with them. Yes.
He's already gone, yes, absolutely.
So now talking about, at least too late to have your Indian LLM and then because ChatGPT, DeepSeek is mostly common.
One way may be to say that you train it in each country. We say that you come to our country and train use our data.
See, here we will have to train in Andhra Pradesh, in Tamil Nadu, in Karnataka, in Odisha, because how much Tamil data you have? You don't. How much Telugu data do you have? How much Bangla data do you have? Not at all, very little. We are stuck there. We have to generate the data. Actually, IIT Hyderabad is doing this. They are holding these hackathons where people come and speak in Telugu in various things. They are capturing that text and converting it for training models, because you don't have enough Telugu data.
I think crowdsourcing is the only way.
I am after, I was talking to some students, in fact I will go there and ask them, I want health data. So I went and checked. See, a lot of people are asking ChatGPT questions about health, and they are actually believing the answers and applying them also. I have a stomach upset, this, that, what should I do? Use this antibiotic. People are buying it. So how good is this? I tested this, brief testing. I took some of the standard benches. There are some data sets available. We tried with the student, I tried Llama, Quen, ChatGPT, Gemma, and one more. We never went beyond 70%. Sarvam was there. 70% accuracy. So 30% of the time it's off. Now what does that mean when people are asking these questions? You know, the other day one friend told me his dog was ailing and he took him to a doctor. He got a bill for his dog for 20,000 rupees. He says, okay, this is too much. I love my dog, but I can't afford it. So he asked ChatGPT and he used homeopathy with the dog. I said, is your dog, did it survive? He says, I survived. I said, very nice, but where is the accuracy in this?
Very often it is a nice storyteller.
Yes.
Use his data and then give a story in a very convincing manner, of course. Yeah.
Yes, and you can ask it repeated questions and it's giving you. How good is this? But we are getting heavily dependent on it. Apparently for psychological counseling, it has gone ballistic. Young people are just going to ChatGPT. It is the highest usage right now for personal use, for psychological counseling. It scares me. What? You're supposed to go to a specialist for psychology. Or go to your friend or your uncle, you know. Don't do this. It's there.
Legal drafting, another example.
So I think a lot of the marketing communications that you may be getting in your mailbox frequently, it's all generated. Everything, they're using these very heavily.
One final question. So we are speaking about artificial super intelligence, right? So these images, because we have RGB spectrum, we created chimeras in such a way that we can view images. We created text in such a way that we can speak to others on a common ground. Does artificial super intelligence mean crossing the human imagination? Like example, you give an example where new images are generated. They don't look good to us, but they may have something coherent in an AI space.
excellent question. Yes. The answer is yes. I don't have them with me, but there are now published images which don't make any sense to us. But an AI reads into it, this is a temple in South India. It looks gibberish, it's just some blur. Why? Because it's picking up the features which are in there. So his question is so good, I have to give a slightly elaborate answer. I know I'm out of time. There is a possibility the whole internet, slowly because of the rise of agents, will shift towards data structures which make no sense to us, but they make full sense to an AI reading them. Okay, today you have Times of India, Hindu, etc. articles which we can read, which the AI is reading. But the question to ask is, why should it be readable to us if there are 5,000 other articles which you and I cannot read? We humanly cannot read it, we don't have time, but the AIs can read it. That's where it will go. The whole internet will slowly morph in both images, video, text and other sensory data which you and I will not be able to make sense of. But it will be more efficient for the AIs to process. It will be compacted, it won't have to render on your screen, it will be much faster delivery. A slightly scary scenario, because then you have this whole world which is happening that you cannot see. It is not in your senses. It's not in the human domain. So I don't want to end on that negative note, but
In that case, thank you, sir, for this wonderful talk. I request the chairman of our committee to please say a few words.
Yeah, it was a wonderful talk, no doubt. Yeah, and it is very relevant for an institute like ours because we deal with a lot of data, and we also run a huge supercomputer here, so that is being used by large number of people across CSIR. So they all bring their data, put it here, and many often we don't know what is the origin of the data, where it is coming from, how to trace it, and labeling, of course, is an entirely different step, as you said very nicely. Don't make one or two to do it, you make 5 or 6 to do it, and then take it sort of stuff. So thank you very much. It was very thought-provoking, and I think it shows that we have more to do rather than just listening alone. So thank you for coming, and thanks to Dr. Anil for organizing this, and thanks to the audience. We also had nice interaction. So thank you.
thank you so much. Thank you for inviting me.